Let's now introduce the concept of heat capacities. Previously, we discussed how our internal energy and our enthalpy are functions of temperature and pressure. Because they're functions of temperature, that means we could also take the derivative of U and H with respect to T. Right? And this derivative is going to be known as the heat capacity of U with respect to T is the heat capacity. Alright? And so the heat capacity is useful. It's measured for many chemicals in the universe. Measured or even estimated based on theoretical models. And these heat capacities are useful because they provide molecular information. And so we can learn more about a particular molecule that's created by a specific reaction just by looking and measuring its heat capacity. Now formally, above I mentioned that the heat capacity was the derivative of U or H with respect to temperature. But back in the old days, before they even had concepts of internal energy or enthalpy, scientists defined the heat capacity as C, and they said it was equal to the limit as the change in temperature goes to 0 of specific heat divided by a delta T. Okay? Now that's just what and that's why we call it a heat capacity, right? Because there's a heat term here. Okay? Now our heat capacity is going to have dimensions of an energy per mass per temperature, or you could even use a molar heat capacity as well. So it would be energy per mole per time. So the heat capacity is the derivative of U and H with respect to T. And so what that means is if you integrate C with respect to T, you'll get back your internal energy or your enthalpy. Alright? And so that's ultimately, why knowing the heat capacity is very useful for our energy balances. Because if we just have heat capacity information, we have some sort of theoretical model that we could use for the heat capacity, that will allow us to calculate internal energy and enthalpy. Okay? And as you'll see in the following videos, there's a couple of different ways or different types of heat capacities out there.